So let's see the question number 1. First, before we discuss the question and answers, we have to know thoroughly what is the solution chapter. In the solution chapter, what are the important topics, right? So in that, colligative properties are what? In the colligative properties, the formulas of the colligative properties and the concentration terms like molarity, molality, weight percentage, volume percentage, weight volume percentage, right? Normality, right? And the normality formula is what? Molarity formula, mole fraction formula. And in the colligative properties, again, osmotic pressure is what? And elevation in boiling point, depression in the freezing point, right? So these all the things we need to know. Okay, then only we can understand, we can clearly solve the questions. So, which of the following is dependent on temperature? The only molarity is depends in the given options. So, molarity will be depends on the temperature, because in the molarity and again normality also, but here it is not there. Molarity and normality will be included with the volume of the solution. So, that volume also dependent on temperature. So obviously the molarity, if you have normality, that is also correct. So now, as of now, molarity we have in the option. So molarity will be temperature dependent. So you know the molarity formula, M, capital M is equals to, this is the formula. So number of moles into 1000 by volume in a ml. That means N is equals to what? Weight of solute. What is that? Weight of, given weight of solute. And N means given weight of solute by gram molecular weight of solute into 1000 by volume in a ml. So that here the volume we are including in this topic, so that it definitely dependent on temperature. So the option is molarity. I hope it is clear. And let's see the next question. If molality of the dilute solution is doubled, the value of molar depression constant Kf will be unchanged. Why it is? First, you have to know the formula. So depression in a freezing point. First of all, you see that if molality of the dilute solution is doubled, the value of molar depression constant. So first, depression constant, right? You know, as you know that I means want of factor, Kf means what? Molar depression constant, M means molality, and Tf means depression in a freezing point after adding the solute in a solvent. So that here Tf is equal to I into Kf into M. So what they are saying, if molality of the dilute solution is doubled, the value of molar depression constant will be no change, so that it is a unchanged we have to, because it won't depends, right? It won't depends on a M. So that if it change or not change, or if it double or not double, it will be same, unchanged. This is the answer. So let's see the next question, children. At the 100 degrees Celsius, the vapor pressure of a solution of 6.5 grams of a solute. Solute weight is what? 6.5 grams and solvent weight is what? 100 grams. So 732 mm means a vapor pressure, so of the solution. And here if Kb is equals to elevation boiling point constant 0.52, the boiling point of the solution will be, first of all, as of Raoult's law, you know that, right? Raoult's law. As per the Raoult's law, we have the formula this is the one. PA0 means vapor pressure of pure solvent minus vapor pressure of solution by vapor pressure of solution is equals to number of moles of solute B by number of moles of solute A. From this, first pure solvent, we know that vapor pressure is 760 mm of Hg minus, and after adding some solute in a solvent, it will be changing into 732 by again solution 732 is equals to NB, number of moles of solute. So number of moles means what? Weight by gram molecular weight. So weight of solute by gram molecular weight of solute into weight of solute A by gram molecular weight of solute B, right? Now 760 minus 732 will be getting 28 by 732. 28 by 732. So 28 by 732. So weight of a solute is what? 6.5 grams. Right? 6.5 grams into here weight of solvent. Weight of solvent means 100 grams into, so molecular weight, this is a A, this is a B. So now molecular weight, right? Molecular weight of a solvent means water, we know that 18. But molecular weight of solute, we don't know, another solvent we don't know. So that we kept it as MB. Understood what I said? Once again, so this is the derivation, pure solvent vapor pressure minus solution vapor pressure by solution vapor pressure. This is the ratio from this, number of moles of solute B by number of moles of solute A. From this, if you write, so weight of given solute A by gram molecular weight and gram molecular weight by given weight. So that will be interconversion, because so here we can write here itself weight of B by gram molecular weight of B by weight of A by gram molecular weight of A. From this, what you can write into, right? So this will go up MA by W. From the same equation here I have written. Okay now, so that WB by MB into MA by WA. So just A and B solute may be interconverted. So but these are the values we have to write. So solute we can write it as a 6.5 into gram molecular weight of A, that means water is 18, by solvent or next solute gram molecular weight they didn't mention, so we have take it as same M into given weight of solvent is 100. From this is the value we have to find. So from this we need to, molecular weight of A is equals to 30.6 grams we get, right? So the unknown gram molecular weight of solvent is that 30.6 we get. From this we will be substituting the next boiling point. So from that if you want to solve that boiling point, first of all you have to know that the delta TB is directly proportional to Kb into molality. That is the formula we need to know. Let's see here, continuation, Kb into molality, isn't it? So the elevation in a boiling point TB is equals to Kb, that means molar elevation boiling point constant into molality, right? From that first TB we don't know, Kb 0.52 into molality. What is the formula of molality? Weight of solute 6.5 by gram molecular weight of solute. What is the gram molecular weight of solute here? We don't know, right? Gram molecular weight of solute we don't know, into 1000 by weight of solvent in a kilograms. What is the weight of solvent here? 100. And here we need to know one more thing, gram molecular weight of a solute. Here just now we have found, what is that? 30.6. 30.6. So that finally we get that delta or TB, right? TB is equals to, after simplification we will be getting 1.10 degree Celsius. How much we get? 1.10 degree Celsius. So that already they have mentioned boiling point of this solution will be. So boiling point of solution will be how much? Boiling point is equals to, generally boiling point it's a already at 100 degrees they started. At what temperature they started? 100 degrees. At 100 degrees they started, and after the changes, all this after adding some solute and vapor pressure, after reaching, it will become 1.10 degrees Celsius. So finally 101 degree Celsius. This is the answer, right? 101 degree Celsius. Okay now, so I hope you understood. So it's a very simple, children. If you know the elevation in boiling point, one of the colligative property, then only you can understand this question. Okay now, yeah. Let's go to the next question. Next, Which of the following statements about the composition of vapor over an ideal 1:1 molar mixture of benzene and toluene is correct? Assume that the temperature is constant at 25 degrees Celsius. Given vapor pressure data is 25 degrees, benzene is 12.8 kilopascals, toluene vapor pressure is 3.85 kilopascals. So now here, what is the correct option? That means first of all you have to know benzene and toluene, they have mentioned the vapor pressure is that 12.8 and toluene is 3.85. Whichever they have highest vapor pressure, so that will be having what? So Kf value and Kb value is also more. And here you can understand here, and even their molality is also more. And as per this data, first, which of the following statement about the composition of the vapor, which have more vapor, that means, so as per this vapor, the pressure, so benzene have 12.8 kilopascals and pressure of the toluene is 3.85. Whichever they have more pressure, that will have more vapor pressure also. So that obviously benzene, so vapor will contain a higher percentage of benzene. Which substance have higher vapor pressure? Obviously benzene, because that pressure is 12.8 kilopascals. So that will have higher percentage of vapor pressure. Next, the Van 't Hoff factor I for a dilute aqueous solution of a strong electrolyte barium hydroxide is, first, the barium hydroxide. So here the barium hydroxide. So what is the Van 't Hoff factor, right? So first, is this reaction balanced or not? Barium hydroxide after dissociation, I is greater than 1 means dissociation, I Van 't Hoff factor less than 1 means association. Now here after dissociation, because I value is greater than 1, so Ba plus 2 and OH minus. So Ba 1 barium ion and hydroxyl ions are how many? 2 hydroxyl ion. So 2 hydroxyl ion and 1 barium ion. So total 1 plus 2, 3. What is the Van 't Hoff factor? 3. I value is 3. That's all. So which one of the following is incorrect for ideal solution? Ideal solution, as we already discussed, so any two solutions if you mix each other, so there should be no change in enthalpy and internal energy also, and even volume also should be equal to 0. So delta H must be equal to 0, and even internal energy and volume also it must be equal to 0, and even total change in a pressure also always absorbed pressure minus calculated by Raoult's law is also equal to 0. But when delta G gives free energy, it will not equal to 0, because as we know delta H minus T delta S. So delta H may be 0, but entropy may not be 0. Entropy may not be 0. If entropy may not be 0, overall delta G also not equal to 0, but they have mentioned equal to 0. So it will be never delta G will be equal to 0 in a ideal solution. So option D is correct. Next, a gas such as a carbon monoxide would be most likely to obey the ideal gas law at a high temperature and low pressure. At this condition only, so they will be following the ideal gas, and they also follow the Raoult's law formula or ideal gas behavior. At this condition only, high temperature and low pressure. So at this condition will be obey as a ideal gas equation. Next, what is the mole fraction of a solute in 1.00 molar aqueous solution? Mole fraction. First you see the molality and mole fraction relation formula here. Molality M is equals to 1000 into number of moles of solute by number of moles of solvent into molar mass of solvent. Here molality we have taken as 1 because they have only mentioned, into 1000 into, right, number of moles of solute. What is the number of moles of solute? So we will be simplifying N by capital N into molar mass of solvent. What is the molar mass of solvent? What is the mole fraction of the solute when 1 molar solution, aqueous solution? That they have mentioned that aqueous, aqua means what? Water. So we must take it as 18 that is the molar mass of solvent. So now here from this we must simplify n by capital N is equals to this one. If you keep it here and if you send it here, 18 into 1, 18 by 1000. Okay, now from this n by n, n means what again? N means number of moles of solute by, so number of moles of solvent means we can also take like this, n1 plus n2. Okay, now n1 plus n2. From this here 18 by, again solute moles are 18 plus 1000. Why we are taking this? Because n by capital N means what? Number of moles of solvent means solute also present in that. After adding solute in the solvent, it became n1 plus n2, that is a capital N. So n by n1 plus n2 is equals to 18 by 18 plus 1000. From this we will be getting 18 by 1018. Finally we will be getting, after simplification, 0.0177. this is the, after simplification we get the answer. So according to the options, that is 0.0177, option D. Let's see the next question here. The boiling point of 0.2 mole per kg solution of X in a water is greater than equimolar solution of Y in a water. So which one of the following statement is true in this case? First of all, the boiling point of 0.2 molal per grams of the solution X in a water is greater than equimolar solution of Y, they are asking. That means what they are saying, X molal, 0.2 molal containing X boiling point is more, greater than of Y in a water. Which one of the following statement is true in this case? So first, if you follow, if you understand clearly the molality they have mentioned, 0.2 X and Y. Okay, so boiling point of 0.2 mole per kilogram solution X in a water is greater than equimolar solution of Y in a water. So which of the statement is correct? So first of all, as per the statement X, so 0.2 is a molality. Okay, now, and their overall boiling point is also more. If they have more boiling point, that means elevation in boiling point it is. After adding solute in X, so definitely boiling point will be increases. If boiling point increases, molality also increases, isn't it? From that, X is undergoing dissociation in a water. That means want of factor also increasing greater than 1. If want of factor is greater than 1, there must be undergoes dissociation. So X is undergoing dissociation in a water. Okay, now I hope it is clear. So finally, X boiling point is more. That means what? Molality also increases. So want of factor also increases. So if want of factor increases, then X is undergoing. That means I is greater than 1. Want of factor I for X is greater than 1. A want of factor is greater than 1. It must be undergoes dissociation but not association. So option A is correct. Next question. Which of the following electrolytes has the same value of want of factor as that of aluminum sulfate? First, for these two aluminum 3 sulfates, so total want of factor is 5 for the aluminum sulfate. And like that, which will be having same want of factor, they are asking. First, K2SO4, SO4 is 1, K2 is 2. So 2 plus 1, 3. But here 5 we need. Next, here K3FeCN6. So 3 potassium ion, and this is one of the complex ion. So total 4 it is. And now here aluminum and nitrate, 3 nitrates, 1 aluminum, 4 it is. Next, 4 potassiums and 1 complex ion, 5. So as per the options, option D is correct, because 4 potassium K plus ions and 1 ligand, 1 complex ion. From this 5 and 5. So as per the question, equal want of factor 5 means option D is correct. Next, which one is not equal to 0 for an ideal solution? Which one is not equal to 0? Obviously, delta G is not equal to 0. Entropy is also not equal to 0. So this will be equal to 0. This will be equal to 0 and this will be equal to 0. Which is not equal to 0 means entropy. If entropy is not equal to 0, delta G, Gibbs free energy change, is also not equal to 0. So option B it is. And which of the following 0.10 molar aqueous solutions, which one will exhibit the largest freezing point depression. Which one have largest freezing point depression means which will have more want of factor. Which will have more want of factor. KCl have 2 and this is C6H12O6. Glucose will not even dissociate or associate because it's a non-electrolyte, and in these two, aluminum sulfate and K2SO4. So as per the want of factor, if you see here 2 plus 3 5 and here 2 plus 1 3 and here 2, which one is correct? So obviously want of factor is more for C option because want of factor I is equals to 5 for this after dissociation 2 aluminum 3 sulfate ion. 5 is a want of factor, and if you see the A and D, want of factor is lesser than option C, and this is not at all dissociate. So as per that, want of factor is more for aluminum sulfate, option C. So this is the relation, children. So what depression in a freezing point is directly proportional to the want of factor. So which will have more want of factor, more depression in a freezing point. So largest depression in a freezing point means for C option. And next, PA and PB are the vapor pressure of the pure liquids components A and B respectively of an ideal binary solution. If Xi A is represent the mole fraction of A and Xi B is represents for mole fraction of B. So what would be the relation? Let's see the answer. Total vapor pressure is equals to sum of vapor pressure of solutes, solute and solvent. PA plus PB. Sum of vapor pressures of a solute and solvent is equals to total vapor pressure of the solution, right? PA is equals to water. PA is equals to, according to the Raoult's law, we have the formula is that total pressure, total vapor pressure is equals to sum of the, right? Sum of the vapor pressure of solute and solvent. So that is what, these are the solvent and solute partial vapor pressure. So that partial vapor pressure PA1 you can write like this, mole fraction of A into partial pressure of A and mole fraction of B into partial vapor pressure of B. So these are the relations. Okay now. So these are the values if you substitute here. Total vapor pressure is equals to, what is the PA1? Xi A PA plus Xi B PB. Total vapor pressure is equals to sum of the partial pressures of A and B we have written. So PA dash means what is the value? Partial pressure of A into what? Mole fraction of A. And next vapor pressure of B is what? Partial pressure, right? Partial vapor pressure of B into mole fraction. So this is the sum value I have written here. Okay now total vapor pressure of a solution is equals to, as we know the relation is that sum of the mole fraction of always equal to 1. Xi A plus Xi B is always equals to 1. From this, Xi A is equals to 1 minus Xi B. From this equation, Xi A plus Xi B is always equals to 1. So this is from mole fraction only we have found this formula, this derivation. So finally Xi A is equal to 1 minus Xi B, or Xi B is equal to 1 minus Xi A. Anyway, any method we can write this Xi A plus Xi B is equals to 1. From that, Xi A is equal to 1 minus Xi B, or Xi B is equal to 1 minus Xi A, right? So these are the two terms, in a two ways you can write. From that, PT is equals to Xi A plus PA. And instead of Xi B, can we write 1 minus Xi A, yes or no? Yes. First, Xi A PA plus, instead of Xi B, can we write 1 minus Xi A or not? Instead of Xi B is equal to 1 minus Xi A. 1 minus Xi A into PB. Isn't it? Now, from this, total vapor pressure is equals to Xi A PA plus 1 into PB, PB minus PB Xi A, PB Xi A. So PB Xi A and PA Xi A. From this, can we take is Xi A as a common? Yes. Total pressure is equals to Xi A as a common. Finally, it will form PA minus PB, right? PA minus PB plus PB. So this is what total vapor pressure is equal to Xi A into Pa minus Pb plus Pb. So can we get anywhere like this formula? Pb plus Xi A into Pa minus Pb, where it is Pb plus Xi A into Pa minus Pb. So as per the options, option D is correct. So I hope it is clear. So from the total vapor pressure, we have derived this equation. So total vapor pressure is equal to sum of partial pressure or partial vapor pressure of solute and solvent. So Pa dash plus Pb dash. Pa dash means what again? The multiplication of mole fraction of a component A into partial vapor pressure of component A, and Pb dash means vapor pressure of solvent or solute, anything you can take. That is the what we can take mole fraction of component B into partial pressure of component B. The same equations we have substituted in the first equation. So we will be getting some of the, these are the what mole fraction and partial vapor pressures. From that, Pt is equals to Xi A Pa plus Xi B. Can we write Xi A plus Xi B is equal to 1? Then Xi A is equal to 1 minus Xi B, or Xi B is equal to 1 minus Xi A. That Xi B is equal to 1 minus Xi A. Instead of Xi B, we substituted 1 minus Xi A, and remaining everything same. From that, total vapor pressure Pt is equals to Xi A Pa plus Pb into 1 Pb minus, and Pb into Xi A Pb Xi A. From that, again we simplified as Pt is equals to total vapor pressure, Pt is equals to, so Xi A, in between these two, one of the component we take it as common. So Xi A Pa minus Pb plus Pb. The same relation have we observed anything in this given options? Means option D it is. I hope it is clear. Good evening children. So let's continue the solution topic. So till now we have discussed 13 questions, and now let's come to the 14th question now. Once you check the freezing point deposition or the freezing point depression constant, freezing point depression constant, right, TF. So the freezing point depression constant for water is minus 1.86 degrees Celsius per mole. If 5 grams of sodium sulfate is dissolved in a 45 grams of water, that means solvent, and this is a solute, the freezing point is changed by minus 3.82 degrees Celsius. Calculate the Van-T factor for sodium sulfate. What is the Van-T factor they are asking? So let's see the formula of depression in a freezing point. What is the formula of depression in a freezing point? TF means if you add some solute in a given solvent, so definitely the freezing point will be decreased. Delta TF is equals to Van-T factor I into freezing point constant, depression in freezing point constant Kf into molality. Okay, now what they are asking, Van-T factor they are asking, means I they are asking. So I is equals to, so delta TF by Kf into molality. This is the formula. So I is equals to delta TF by Kf into, what is the formula of molality again? So weight of solute by gram molecular weight of solute into 1000 by weight of solvent in a kilograms. So weight of solute by gram molecular weight of solute A and A into 1000 by weight of solvent. This is the formula, weight of solvent. So if you send this value up, what will happen? I is equals to, so delta TF into, see what will happen, this MA and WB will be go upside, MA into WB weight of solvent divided by Kf into WA into 1000. Okay, so the delta TF, what is the delta TF? It is minus 3.82, means 3.82 into, so molecular weight of solvent 45. So molecular weight of solvent is a 45 and given weight of solute B is a 45. What is the gram molecular weight of solvent? What is the gram molecular weight of solvent here? So H2O is a 18 and delta TF is 3.82 by KF. What is the KF value? Depression freezing point 1.86 into. So here itself I am going to write that. So solute weight and gram molecular weight of solute weight. So solute weight is about 5 by. So gram molecular weight of solute Na2SO4 is 142. Actually this 142 can be written on the numerator itself, but here only I am writing. So first delta TF I have written and this is the value here only I have written. Don't get confused. This Ma value here only I have written. So solute weight by molecular weight of solute 5 by 142 into 1000. That's it. And delta TF itself same. And next, what is a WB? So WB means a given weight of solute. What is the given weight of solute here? 45. What is that? 45. Okay. So once again, everybody listen here. So they are asking Van der factor from this formula. So depression in a freezing point delta TF is equals to I into KF into molality. From that, I is equals to delta TF by KF into molality. From that, Van der factor I is equals to delta TF by KF into molality formula. From this, that's it, simple. We are just substituting all the values here. So delta TF value is 3.82 into, right, 3.82 into, so molecular weight of solute A and given weight of solute A. So this is the value here itself I am writing. This is the same value here I am writing like this, right. WA means given weight of solute by gram molecular weight of solute 5 by 142. And next 1000, but this given weight of solute, second solute weight, I am going to write it here 45. That's it. After simplification, so from this finally we get the Van der factor is equals to 2.63. After simplification, so here I am not explaining the complete solution simplification. I have given the way how we write, how we substitute the values. Finally, Van der factor we will be getting as 2.63. This is the answer. I hope it is clear. So this is what from the depression in a freezing point you can find. Next, you see the next question, the Van der factor I for iodine for compound which undergoes a dissociation in a one solvent and association in a other solvent respectively. So first dissociation according to the Van der factor, when Van der factor if it is greater than 1 means it takes dissociation, less than 1 means it takes association. First dissociation and then association. So dissociation means what? Greater than 1 and association means less than 1. So less than 1 and less than 1. No, dissociation means greater than 1 and less than 1. Option B. Always for dissociation means Van der factor should be greater than 1, and association means less than 1. So option B is correct. It is according to Van der factor, which we already discussed in what osmotic pressure. So or even depression in a freezing point of the solution topic. Okay now, so that I is greater than 1 means dissociation takes place, I is less than 1 means association takes place. So dissociation means greater than 1, association means less than 1. Next, an aqueous solution is 1 molal in a potassium iodide and which change will cause the vapor pressure of the solution to increase. Always one thing you remember, if you add any solute to the solvent, especially non-volatile solute to the solvent, so generally pure solvent vapor pressure will be very high as you compare with a solvent added with a non-volatile solute. Yes or no? Pure solvent if you heat in a closed system, so that heating will be increases the boiling capacity of the solvent which we have taken, that will be increases and increases the vapor pressure. So that vapors will be increases the vapor pressure inside. That is for pure solvent. After adding solute to the solvent, that vapor pressure definitely lesser than compared to the pure solvent. So, but in given a substance which after adding which substance again increases the vapor pressure, this is. If you add any non-volatile solute, then definitely it decreases the vapor pressure. but only solvent we have addition of water. If you add, it increases more, vapor pressure will be more, because it is not a non-volatile solute. This is a solvent, also increases the quantity of the solvent, pure solvent, so that it will be helpful to increase the vapor pressure, and also surface area also increases. So option D is correct. Remaining NaCl, sodium sulfate and potassium iodide, these all are have non-volatile solutes, these all are. So this is only the solvent which increases the vapor pressure. So option D. A solution of sucrose, molar mass is 342, has been prepared by dissolving 68.5 grams of sucrose in 1000 grams of water. Okay. So first, a solution of sucrose prepared by what and what? 68 grams of sucrose in 1000 grams of water. The freezing point of the solution obtained will be, what will be the freezing point they are asking? Just a freezing point they are asking. Let's continue. So depression and freezing point, same formula again. From the depression and freezing point formula only we will be finding. What is the depression and freezing point formula? Delta TF is equals to I into KF into molality. First of all, we need to find the molality from this. So molality M is equals to weight of solute by gram molecular weight of solute into 1000 by, okay, weight of solvent. From this, molality M is equals to, given weight of solute, what is that? 68.5 by gram molecular weight of solute, means sucrose is 342 into 1000 by 1000. This is after substituting the values from the given question. So that 1000 and 1000 gets cancelled. Finally, molality we will be getting, molality M is equals to 68.5 by 342. So this is the molality we are getting, children. This is the molality. This molality if you substitute in this formula, let's see, delta TF is equals to, first I. What is the I Vanta factor? For this, solution of sucrose has been prepared. Is there any Vanta factor? The freezing point of the solution obtained. So here not required Vanta factor, so we can remove this. So here Vanta factor is not required, so we can remove. And finally, delta TF is equal to, what is the KF value? KF value is 1.86. 1.86 into, what is the molality? 68.5 by 68.5 by 342. Okay now, 68.5 by 342. So this is the delta F is equals to. So finally, delta TF is equals to, if you simplify, so 1.86 into 68.5 by 342. First 1.86 into 68.5, if you multiply, we get, how much we get? 5 6 the 30, 5 the 40, 43, 5 1s are 5 plus 4, 9. So 127.4 by 342, children. 342. Finally, we will be getting the value 0.372 we will be getting. Okay. So as per the option 1, 0.372 degrees Celsius. Sir, here positive is there, negative is there. How can you choose a negative value? Because so for that we need to do the subtraction. How to do? Let's see. For this, finally what we are getting? 0.372. 0.372. So finally we will be getting delta TF is equals to, right, T naught, TF naught minus TF. So TF naught is 0 degree initially minus 0.372 degrees Celsius, finally minus 0.372 degree Celsius. So according to this, option A is the answer. Okay children. Next 18th question here. 25.3 grams of sodium carbonate, right, is dissolved in enough water to make a 250 ml solution. If a sodium carbonate dissociates completely, molar concentration of sodium ion Na plus and carbonate ion are respectively. So it's a very simple. So they are asking the molarity. Capital M means molarity. So from the molarity formula, what you can write? From the molarity M, capital M is equals to given weight of solute by gram molecular weight of solute into 1000 by V in a ml, volume of solution in a ml. From that, what we can find molarity. So first 25.3 is a given weight, 25.3 by gram molecular weight of solute. What is the gram molecular weight of solute? They only mentioned 106 into 1000 by 250 ml. 1000 by 250 ml. This is a molarity. So 250 ones are 4s are. Okay now. 250 ones are 4s are. 4 ones are and 4 2s are 8 and 2 is left here. So 26. 4 6 are 24. How much? 4 6 are 24 and 2 again 2 left. So 20. So 4 5 are 20. 25.3 by 26.5. So it's a 25.3 by 26.5. After decimal, so we have one digit, so we can simply cancel them and write 253 by 265. If you divide, we almost will get 0.95 we get, children. Around the value is 0.95 we get. So that is for molarity for sodium carbonate. But they are asking the sodium ion, carbonate ion respectively. So first sodium ion will be 0.95. Okay, and next and after that, how much we get? First of all, after dissociation of sodium carbonate, Na2CO3. Let's see how much we get at 2 Na plus plus 1 carbonate ion. So here 2 sodium ions and 1 carbonate ion we are getting. So we have found one of the ion, that is a carbonate ion. It is only one ion, and the same concentration will be reached to the sodium also. But here 2 moles we have. That means this is for carbonate ion, and for sodium means 2 into 0.95. If you get around 1.91 we get. This is the second, this is the first one. So as per the options, we'll get first one is 0.95 molar and the second one is 1.910 molar. So this is the option. So this is a very simple. From the given data in the question, I have substituted as per the molarity formula, because capital M means molarity, small m means molality. Okay, I hope it is clear. And next question, let's see. A 0.0020 molal, small m means molal, aqueous solution of an ionic compound, so cobalt pentaamino nitrochlorine, freezes at a minus 0.00732 degrees Celsius. Number of moles of ions which 1 mole of ionic compound produces on will be being dissolved in a water will be Kf, means molar depression of freezing point constant Kf they have mentioned. What they are asking? So the aqueous solution of ionic compound. So what they are asking here? The number of moles of ions, which 1 mole of ionic compound. In a 1 mole of ionic compound produces will be how much? They are asking. So it is only it depends on molality formula only, and they have mentioned Kf, molality also we have. So if you substitute from that, easily you can get it. And here they also given that what they have given. So it freezes, means a depression in a freezing point, and Kf they have given, Tf value they have given, and molality also they mentioned. So let's see the same depression in a freezing point. Formula is what? Delta Tf is equals to I into Kf into molality. I into Kf into molality. And here from this I we need to find. I is equals to what, children? Delta Tf by Kf into molality. And again from this I is equals to delta Tf is what? What is the delta TF? We have 0.00732 we have, and by is divided by Kf at 1.86 into what is the molality? Molality also they only mentioned 0.0020. From this, if you find almost Vanta factor from this given value, we will get so 1.92 approximately 2 we get. So if Vanta factor 2 means it is only decides how many ions after dissociation or association from the given compound. What is the compound? We have ionic compound. What is the ionic compound we have, children? So here this is the complex ionic compound. Once if you dissociate, we will be getting 2 ions. 2 ions because Vanta factor is 2. So ions are also, number of ions are also 2. From this, so we can find that 2 ions will be possible in the given compound. Next, an ideal solution is formed when it's a components. So when the ideal solution is formed, when it's a components, have no volume change on mixing, have no enthalpy change on mixing, have both. See, one thing you remember, ideal solution means what? If two solutions mixed each other, there should no change in a enthalpy, there should no change in a volume also. So above two options given in a C, so have both the above characteristics, that is a correct option. So option C. Next, concentrated aqueous sulfuric acid is 98% by mass and has density is 180 gram per ml. Volume of acid required to make 1 liter of 0.1 molar sulfuric acid solution is. For 0.1 molar, sulfuric acid, how much it required? Yeah. So let's see. From this given data, we can use the normality formula here. Normality is equals to weight percentage into density into 10 by equivalent weight. And normality is equals to weight percentage into density into 10 by equivalent weight. This is a formula. Equivalent weight. So this is from normality formula we will be getting. So normality N is equals to, so weight percentage they only mentioned 98% into density. What is the density? We have 180. Density is 180 into 10 by equivalent weight of sulfuric acid. How to find the equivalent weight? Equivalent weight is equals to atomic weight by its valency. So this is the equivalent weight because atomic weight of or molecular weight of sulfuric acid is 98 by its valency, means number of ions can be shifted from the H2SO4 means 2H plus. So 2 it is. So 98 by 2, that is a 49. So equivalent weight is 49, children. So finally we get the normality. After simplifying this, we will be getting 36 is a normal. So this is a N1 normality 1, children. Normality 1. And next N2 normality 2 also we need to find. N2 is equals to, so N2 we need to find. N2 means from the given solution H2SO4, so that valency of H2SO4 is 2 into concentration is 0.1. So finally N2 is 0.2 N2 it is. So this is N2 and this is a N1. The overall formula N1 V1 is equals to N2 V2 it is. N1 is 36 into V1 is equals to N2 is 0.2 into V2. And now here we have V2 value also, right? Because 1 liter V2 means 1000 ml we can substitute here, right? From that, how to find the V1? V1 is equals to 0.2 into 1000 by 36. Finally, V1 is equals to around 5.56 ml we will be getting. 5.56 ml. So that is option D we will be getting. So as per the calculation part, so 5.5 or 5.56 ml we will be getting. So from this equation, normality from the given data. I hope it is clear. And next, all form ideal solution except, all form ideal solution except what? Ethylene iodide, right, or acetylene iodide and ethanol, ethyl alcohol. Because so when two solutions mix each other, there should no change in enthalpy and volume also. So above these three solutions, there is no change in a delta H and even delta V always equals to 0. But when you mix these two, there will be change in enthalpy and volume also. That is the reason except this, above three act as an ideal solution. And next, 23rd, the relative lowering of vapor pressure is equal to the ratio between number of. RLVP, relative lowering of vapor pressure, is always equals to its mole fraction, solute mole fraction of the solute. Mole fraction of the solute means what? So number of moles of solute molecules to the total molecules of the solution. N1 by N1 plus N2, that is a relative lowering of vapor pressure. Okay, P naught minus P by P naught. Okay now. So that is a question, that is a relation between RLVP versus mole fraction. So as per that, we get the option B it is. So which of the following aqueous solution have minimum freezing point? So here 0.01 molar of NaCl, because you see the Van der factor for this, after dissociation of NaCl, 1 Na plus 1 Cl minus. Okay, and molality of this is very less, 0.01 it is. Molality is minimum and even Van der factor we get very low, so only 2 ions will be dissociated. And here how many ions? 3, and there is no, it is non-electrolyte. Here we also getting C1 sulfate ion, 1 Mg plus 2 ion with a 0.005. So molality is somewhat more. So here 0.01 with a minimum molality and Van der factor, because 2 ions are producing. So with this, option A have minimum freezing point. Next, blood cells retain their normal shape in a solutions which are isotonic, means there should no change in a shape and a composition. So those are called as isotonic in nature. So blood cells will not be changed, their shape are called as isotonic in a nature. So this is the test 1 in a solution topic. Thank you.